Alright. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you'd better figure out what's wrong. Each segment of a 7-segment display is rendered by turning on or off any of the 7 segments named A through G. Okay. Backseating is always welcomed. I called my stream this because I am inviting people to come and tell me things. I would have come up with a different name. No, you're absolutely welcome. I'm always ready for tips. Okay, so 7 segments display, A through G. So this looks fine, right? This looks gross but fine. So to render a 1, segments C and F would be turned on. So C and F. The rest would be off. To render a 7, you would add the A's into the mix. Like this. There is actually an example of a numeral 7. Okay. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each 4-digit display. All of the digits within a display use the same connections though. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. So B and G. Yeah. The only digit that uses 2 segments is 1, so that must mean segments C and F are meant to be on. With just that information, you still can't tell which goes to which segment because, you know, like we know that C and F and B and G have been crossed, but we don't know if B is C or B is F. For each display, you watch the changing signals for a while, make a note of all 10 unique signal patterns you see, and then write down a single 4-digit output value, your puzzle input. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. So this is a test, and this is going to be... I actually don't think this will be much more involved to pass. We just need to split and then call words, right? But that said... I don't know, we're gonna do some character nonsense. I've got to decide whether I use data.text or just data.string. ACE, so the signals, so this is like a digit, right? Each entry consists of 10 unique signal patterns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay, so in this case, this is 8, right? Because everything's on, and when everything's on, we've got a digit 8. This, as it was saying before, is our digit 1, but AB. So we don't know. We know A and B have been miswired to C and F, but we don't know which one is C and which one is F. Yeah, all of that to say the order's going to be jumbled. Oh, Advent of Code takes its theming very seriously. You know, the submarine mission. I love it. Within an entry, the same digit, same wire segment connections are used. You don't know what the connections actually are. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the correct wire segment connections. Because 7 is the only digit that uses 3 segments, the render of 7, yep. 4 is the only one that uses 4 segments, etc., etc. So we can work out which combination of wires corresponds to each digit, then we can decode the 4-digit output value. Unfortunately, we get these 5, so they're all 5 segments, right? So you can't just quickly decode this, because 1, 2, 3, so this uses 5, this like 2 and 3 are the same, they just have one thing swapped. 5 is the same, 6 has an extra one. Yeah, cool. Okay, so they're all 2s, 3s, and 5s. We don't know like which is which. Using this information should work in which combinations, blah, blah, blah. Focus on the easy digits. So for part 1 of this, we get an easy part, right? Because the digits, count only the digits in the output values. The part after the horizontal line. Okay. In the output values, how many times did the digits 1, 4, 7, or 8 appear? Awesome. Easy. So So we've got a really big setup. We're going to have an easy part 1 and then a hard part 2. Part 1, thankfully, yeah, going to be very, very easy. So let's... hold on, let's actually commit our solutions to day 7. Holy crap. Solve... solve day 7. I guess I'll push as well. Perfect. Okay. So I don't think we're going to do any fancy data modeling. In the last one we had a crab type. I think we're just going to use strings. I don't think there's anything too crazy, right? Because we're just going off the length of strings. So we're counting the number of strings that have a length that is equal to 2, what is it? 2, 4, 3, or 7. 2, 4, 3, or 7. Okay, so solve is going to go from a list of strings to an integer. It's going to be, okay, so we start with a list of strings. Let's draw this out. Do I want to... I drew this on the background like a freaking scrub. Let's... Alright, we're going to go a new image. I'm going to start with this. We're going to... that's not what I wanted. Cool. We're going to actually make a new layer this time. Okay, day 8. Part 1's easy. List of strings. We want to go to a list of integers, right? So a list of the length of those strings, then we're going to filter that down to another list of integers, and then we're going to go down to a final single integer, and so along the way, right? So this is going to be length. This is going to be a filter. So we're going to filter out things. We're only going to keep things that have a length of 2, 3, 4, or 7. Equals 2, 3, 4, 7. And then we're going to sum. And that's it. That's how we solve day 1. Saw an alert on the screen for a follow but no sound. Yeah, I may have turned sounds off. I'm still playing around with how I actually do all this stuff. I tend to keep things pretty minimal, especially because I upload all of these to YouTube primarily and get most of my views and stuff through YouTube. But I'm definitely open to adding some sounds in. I feel like I need to get someone to design some sounds or something, or maybe build them myself. I wonder if I could program sounds. Anyway, I've got fun ideas. I think it'd be fun to do some streams where I build some stuff to make my streams better. But yeah, thank you very much for the follow either way. Okay, so length, filter, sum. And we can combine these things together with f maps. And we can actually do this all in one f map, right? So we can combine sum, filter, and length into one super function and then apply it to our list of strings at the get-go. And that literally just looks like this, right? So length, filter, x equals 2, or x equals 3, or x equals 4, or x equals 7, sum. And then we just apply that to a list of strings, which is, well, so we fmap this, or even just say, no, let's go the sensible one at the start, right? So fmap, again, let's just quickly touch on this, right? Because I used fmap in my previous one, but it wasn't quite as important as here because this is literally just a one-line solution. So fmap is a function which takes in a function from A to B and gives us back a function. And this is a slightly different way of writing it than you'll see in most places, but it takes a function A to B and it gives us back a mapping between an f of A and an f of B, where f is, for example, a list. Hold on, my sum doesn't. If you look at this and think about what I just said, the sum does not belong here, right? This length lets us go from a string to an int. Filter lets us go. The filter and the sum don't belong here. Sorry, I'm getting too excited when that point's free. So the filter and the sum need to actually go outside of the fmap. And we can actually then just say it like that. Yeah, that's cool. That's cool. So yeah. So length does something to the things inside the list. So we fmap it over the list, right? Length goes from string to int. So we can use fmap to go from a function from string to int to a function from list of string to list of int. And then we filter on top of that to cut things out, and then we sum down from that. So if I exit out of here, I go over to day 8. This might yell at me. It does. Something has gone wrong. Oh yeah, hold on. Whoa. You still do them in the same order. I got too keen. I got a little bit ahead of myself. And something's gone bad. Expected string to int actual. Okay, let's build this up in smaller pieces. Okay, and this is something I like to do. Because I'm still a bit of a Haskell noob, right? I'm biting off more than I can chew. So let's go simple, right? So type fmap length. Okay, so this, we can imagine this as being, so we can imagine this as being list of string to list of int. For all intents and purposes, this says list of string to list of int. Fmap length equals 2. Okay. So this is fine. Fmap length, we can combine a filter on after this, and so now we go from list of strings to list of numbers. That's fine. That's what we wanted to see. And then we can chuck a sum on the end of this, and now we're going to go from See, I know that this is going to give me what I want, right? Or not? Maybe sum isn't G of A to A. So yeah, so foldable. So if I say X is fmap length of filter equals 2, I can say X of foo bar r, and I should just get a list containing length. No instance for numcar arising for use. Tx num list of ta. So I can fmap length over this, right? This is just shorthand for saying fmap length. So that's fine. So fmap, let's just like store this somewhere so that I can pull it out. So let's say fmap length s. That's fine. Wait, am I applying them forward instead of? Oh, I've got it. I'm doing them in the wrong order, aren't I? Lambda x goes. Let's say filter equals 2. Yeah, I'm doing it backwards. Oh, I'm doing it backwards. Perfect. That explains it. That explains so much. When you're doing, this is called points freestyle. So this means that I can define like this. I can store this in a variable, and this becomes a function that does these things. Oh, we got a spam bot. Let's get rid of that. Oh. Cool. Spam bot gone. Okay. that explains why that was so angry at me. So sum of filter, let's say, let's do this, just so that we have a slightly nicer line to read. So f of x equals 2, or x equals 3, or x equals 4, or x equals 7. Perfect. Now main is going to be equal to do. Now the parsing here is going to be harder, isn't it? We need this split words function from words when function rather. So just so we can split at input up. Do input is read file input let let's just say let display, I guess, equal words. Okay, so we're gonna have lines of input, right? So for each line of input, displays. For each line of input, I already grabbed it. Okay, cool. So each line of input, we split this, we divide these into words, so we get a list of strings. So we're going to have a list of strings. So it's going to be, so lines input gives us our lines, but then we need to do some more processing to these lines. So the first thing we do is split, and then we say words. So words of split, words when, but we want to get the second part of that. So let's kept equals, because we're going to throw some stuff out and we're going to keep some stuff. We're going to throw this out for each line, we're going to keep this. So let's say kept equals words when equal to, so we split on this character, but then we only keep index 1. We throw out index 0. And this is not a safe way to approach this, but because Advent of Code always gives us well-behaved inputs, we roll with this. So we have what we keep, and then we say displays equals, perfect. Does Haskell have tuples? Yeah, you can just kind of go 1, 2, 3, whatever. In this case, we could pass things into tuples. We're not going to go that extra step because I don't think there's much to gain from it. Strings have really good sane implementations of fmap and stuff. Tuples are a little bit more complicated. They're good for many things. I think some of the other Advent of Code problems I've solved using tuples for things like coordinates, like XY coordinates. Yeah, highly recommend Haskell. If you're interested in learning Haskell, this book taught me a lot. I hear people have mixed criticisms of this book. I think it's really good. You can read it online for free. It goes through a lot of really cool stuff. It got me started, but it left me leaving a lot. Wanting for a lot. List string. I could, again, because I'm just throwing everything away in the first part, I'm just going to go for the simpler thing for now. Going from, okay, ultimately when I call words, it's going to get split into a list, because that just makes more sense in a Haskell world. So I could then convert that list into a tuple, but I don't gain anything in this case. But yeah, I definitely could. Tuple applicative is useful. Yeah, true, actually. I always forget how good lift A2 of that is. I like it, yeah. I don't use applicative enough. Every time I use applicative in a good way, I feel very smart, and I pat myself on the back. But, I don't know, when I was doing the most Haskell, that was probably in late 2019, so I'm a little bit rusty. I've forgotten more of the theoretical stuff that I knew, and I'm just kind of like throwing stuff at the wall and seeing what sticks right now. Okay, so we've got a list of displays. So then what we just want to print out a solution. Adpex twin dong. Thank you very much for the follow. Welcome to the show. That is a high quality name. That is a high quality name. Was Apex twin dong taken, so you had to add the D in there? Or was that an intentional thing? Was that a stylistic choice? Kept. Oof. Okay, hold on. Oh, hold on. I did something odd here. I need to. Oh yeah. Whoa. Okay, let's go. Let's go lines here, okay? Because we've got lines of input, right? We've got lines of input. For each line, intentional. The name was intentional. That's good. I'm glad you got the name you wanted. For each line, we need to say split on this character, the bar character, then. Well, I guess, kind of like index 1 of this, we call words, and then we solve for this. So here we want to end up with a string. Here we want to end up with a list of string. And then here we want to end up with an int. And then ultimately we're going to end up with so we're going to go from a list of strings to a list of ints, right? So we want to, we're thinking, this tastes like an F map, right? This is a list of strings. We're going to end up summing a list of integers to get our final answer. So. It might actually be easier to just, maybe I shouldn't have called this solve. Maybe I should have called this, let me just call this count instead. And then we'll say solve. We'll go from, I don't know, does this mix parsing and, I don't know, I don't like it. I feel like something dirty's happening. Let's keep this as solve. Okay, so we've got a list of lines, right? Our input is a list of lines. I don't know I need a clean way to do this, right? So let's go back to what I was doing before. Let's do it in a more sensible way, right? Words when okay, so we're gonna split for each line. We're gonna split the line on this character. And then we're going to keep the first part. And I think that's going to have the right... I'm going to bracket it just to be sure. And we're going to fmap this over input. So now we have a list of strings, but the strings are only this. So now we can do this part, right? So now we can just do the fun part. We can say print sum... solve, print sum fmap solve, right? So solve, solve. So we split it into words and then we solve for that, right? This works. This doesn't work. It was a good idea. It was a valiant effort. Could not match type IO with list. Is this associating... Is this... Does... interesting, because Because let's just test something out in the interactive thing. Okay, so let's go solve equals sum of filter of fmap length, right? Solve goes from let's list of string to int. So what if I say, what's the type of this? This goes from a list of string to a list of int. And then a sum goes from a list of a to an a, where a is a num. I'm not saying where this doesn't line up. I'm not saying where this is angry, right? Print. In the expression, could not match type IO with this. Kept. Does kept not have the right type? Is kept somehow not a... So what about... but none of the stuff is in scope from that import. That's annoying. Okay. Let me think. This appears to be right. It's just somehow... Let get user in sum of fmap solve words kept in print potato. Let's see what happens. When in doubt. Oh, okay. Yeah, no, this is... What? What? Main equals main? Main's an IO. Why are you expecting main IO? IO unit. What are you expecting? What's going on here? I've never seen that before. I've never seen Haskell try and infer a wrong type for main like that. Baffling. Am I in the... What is going on? Okay. Could not match type car with list of car. So, input. Input is a list of strings. Input is a list of strings. When we fmap over this, namely input, expected a list of string, actual string. This is saying that input is just a string. Oh, because I'm linesing... Yeah, hold on. Whoa. This... you can't lines over this side because this gives us an IO string, not a... You'd have to... I mean, you can lines... You can do that, right? This should work. Yeah, perfect. Except we don't actually have an input file yet. Let's see what happens when we get an input file. Oh, we just print out potato because... Of course we do. I have to reload. Could not match type because this should be a print. Then it's going to do all the conversions it needs. And then if I just say main, it's going to give us this magic number, which is going to be the solution. We're not going to have to go back and solve any problems. Okay, it's not the right answer. You don't need the IO thing now. Yeah. Something went wrong there. Okay. Oh yeah, that was almost certainly the problem, right? The fact that it was doing some real weird type stuff. This will be fine now. Yeah. that was the problem. Okay. So what's going wrong? Let's take this test input line. Let's just take these. We've got to wrap them up in a blanket and turn them into nice, well-behaved strings. What is? Okay, so now we should be able to test this out with solve test. And that looks like an absolute wrong answer. We can say that for sure. Oh no, that is what we expect, right? Because these are all length 5. Yeah, so if I add, for example, an AB in here, this should just now be length 1 or length 2. Okay, there we go. Oh, hold on. I actually want the length of this, not the sum of it. That'll do it. So now if I go main, that explains why the number was too high. I'm going to come down. This is going to be my answer. It's going to be correct this time. 1 gold star. Perfect. Let me see quickly if part 2 is going to be much harder. Should be able to determine the remaining digits. Oof. Oof. The mapping between signal wires and segments only makes sense in the following configuration. Oh dear. Oh dear. Time for a pen and paper. Yeah, this is a bit more involved. The first example above. Okay, so oh wow. Oh wow. This one's a thinker. This one's a thinker. I might actually hold on. Let me check and see what's happening in day 9. Because I think this is just too involved for me to do right now.